Hi guys, good morning. Welcome back to the new video. Oh god, and this problem is awesome, like legit awesome. Especially thinking logic, it's fine, it's very fine. But thinking of the cases, okay, why to sort it, why, like how to put the code. Okay, we have sorted logic, but people have just put the code as it is. So yeah, in that case, thinking the logic maybe easy. Okay, it's a simple recursion and stuff. We can do it. Simple memoization, we can do it. But thinking of the how to write the code first part and how to case, okay, how to handle the cases, okay, it is coming like this, it is something like this, and how to think, okay, what to memorize and stuff. We will see exactly everything. Cool. Let's start the video itself. I know it's already pretty late. I have also missed the contest. I have to give the contest after this also. But yeah, cool. Let's start with this. Minimum cost to cut a stick. The question is pretty simple, that we are having a wooden stick of length n units and the stick is labeled from 0 to n, which means the length n. For example, a stick of length 6 is labeled as follows, as it is given below. Cool. We are given an integer array called as cuts, where the cuts of I, it denotes that the position you should perform a cut at. Cool. Basically cut shares, okay, I need to cut at this location and you should perform the following cuts in the order. You can change the order. You should perform the cuts in order and you can change, okay, the cut order I can change. Okay, when, what position to cut, it is given, but I should cut 3, I should cut 2, that order I can change of cut. Okay, the cost of one cut is the length of the stick to be cut, which means right now I'm cutting at 3. The stick was actually the length 6, so the cost of cut is 6. But then my stick right now, let's say, is 3. Now I make a cut at 1. Now the cost of this cut of 1 is 3. Because the stick remaining was actually of length 3. So as soon as I'm putting a cut, the cost before that, the length before that is the cost. Cool. We have to find what is the minimum cost of the cuts, which means I can change the order by myself. After changing the order, whatsoever it is, what is the minimum cost? Now, if we just have this question, we have, the rod, the stick is of length 7 and the cuts are these. I have to, it's not saying the ordered cuts. It's saying, okay, the cuts are 1, 3, 4 and 5. You can cut them in any order you want. So let's say if I just cut them standardly as they are given, if I just make a first cut initially, so the length was initially 7. So its length is 7. Now it just broke down to again 2 pieces. Now if I just make another cut of length 3, but now it is the rod of length 6 itself. So I just make a cut, but it is on rod 6. So it is like this. The cost incurred will be 6. Now it again broke down to these 2 pieces. Again, I make a cut at 4, but cut at 4 is made at a length of rod 4. So I make a cut at 4, but again at a length of rod 4. So the cost is 4. Again, it just broke down to these 2 pieces. Again, the remaining piece of length 3, I make a cut at 5. So I make a cut at 5, but 5 cut at a rod of length 3. So basically, ultimately, I did all the cuts. So the cost incurred was 20. But is it the minimum cost? Maybe, maybe not. According to the question, the minimum cost will be incurred if we just do the first cut at third location, which means I did third location, although the length was initially the whole length. So the cut cost is 7. Now it broke down to these 2 parts. Again, let's say the question says I can make a cut at 5. Now the cut at 5 is made at this length, which is of 4. So I make a cut at 5, but at length 4. That's the reason the cost is 4. Again, it just broke down to these 2 parts. The question says I can make a cut at 1. Cool. I make a cut at 1, but the cut at 1 was made at this part, which was actually of length 3. So the cost of this cut is 3. Now I just have again these 2 parts. Now I make the next cut at 4. The next cut at 4 was made at the length 2. That's the reason the length 2 was impacted. So the total cost finally is 7 plus 4 plus 3, where the 3 is gone, plus 2, which is 16. That is the reason we can see, okay, it was lesser than this 20. So now one thing I'm very sure. At initial point, which means I here started with the cut as 3, not as 1 or 5 or anything. But I initially had options. I can either start with 3 cut, with the cut as 3, at 5 as 1 or as 4. So basically initially I had 3 options. So what I will do is I will just have initially, okay, I have X options to cut. Cool. Let's say I choose any one options. In the next iteration, I again have to choose between all these cuts, which means again in the next iteration I will have X minus 1 options to cut. Next iteration, x minus 2. Then so on and so forth. Which means if I just go by the standard brute force recursion way, then at first iteration, at first option, I have x options to cut. I can cut at 3, 1, 5 or 4. And for sure, I know that I can't go greedy way, that I can't cut initially at 1 or 3 or 5 or 4, because I know that there can be any combination which can give me the maximum cut possible. So I know, okay, it's x factorial, but if we see the constraints, that will actually go very long. That would for sure not pass. So for sure, we have to think of, for sure, it's a recursion, we saw, because we will try on every location, then we will split that stick, again try on the again cuts. We saw, okay, we have an intuition, okay, it's a recursion, but also we got the intuition that, okay, it might have a repeating subproblem, because for sure, I can't compute the entire recursion by itself. That won't go. That won't work. So if we simply go and have a look at the cuts again, then what will happen? At the first initial option, I have the option to cut at this index 2, right? One option is to cut at index 4, one option to cut at index 5. Initially, I'm saying initially at the first cut, I can choose a first cut as index 2 or 4 or 5 or 7. It is a first cut I choose. I can choose, I have these x options to cut because I have x cuts initially. Now, as soon as this first cut is done, right? Again, I will have again 3 options to choose. Maybe I can just cut here or here or here, right? So again, I have again 3 options. Let's say again 3 options are there. I just make one option only. Let's say I just made, in the next step, I just made a last cut here. Again, for this example itself, I will have again 3 options to cut. Simple as that. Again 3 options to cut. But I just make, let's say choose only the last option to cut. Now, again, all these will again have 2 options to cut. Again, we'll have 2 options to cut. I can again choose any order. Okay, I can choose to cut this or this. But if we see, it has this area has 2 options to cut, and the same part is repeating again. That's the reason. I know I have to make the cuts, but I can easily see that it has a repeating problem. That is how we know, okay, we can make some recursion. For sure, that recursion was very big because I had to try all the possible cuts at all possible time, at all possible point of time. So for sure, it has a repeating problem. Now we know, okay, it's recursion, it's memoization, but how is a recursive call being made? Okay, what is the recursive function? What we have to write? Let's look at this now, which means if I have the stick, so basically what I want is I have the start and end stick, and I also have this left and right of the cuts, because for sure, I have to, at any point of time, that let's say I apply a cut here. So I have to say, okay, right now the stick length is this and the cut range is this. The stick length is this, the cut range is this. At any point of time, if I'm choosing any cut, I have to bring 2. Basically, it is exactly same as merging intervals. Kind of. You have your main interval, you broke down to 2 intervals and then you merged it. Kind of like that, right? So you have your stick, you broke down that stick, then you have your left part, which is again a stick, right part, which is again a stick, left cuts, which is again left cuts, and right cuts, which is again right cuts. That's the reason. When you make a cut, you just broke that stick into 2 halves, left stick and right stick. And also the cuts will go, left cuts will go to the left stick, right cuts will go to the right stick. Now, Aryan, it was never said that the cuts are sorted, which means cuts can be in any order. In the question given, the cuts can be in any order. Let's say 3, 2, 1, 5. But as soon as I put a cut, let's say at 2, I want all the cuts which are, because if I put a cut at, let's say 2, then all the cuts should come before it and all the cuts should come after it. Because for sure, right, if I put a cut at 2, then I want all the cuts at the left part of 2, all the right cuts at the right part of 2 to give, okay, right cuts to the right stick, left cuts to the left stick. So basically, if it had not been so sorted, if I had to give the left cuts to the left part, I have to iterate on this entire cuts array and would have to give, okay, 1, you should go to the left, and 3 and 5, you should go to the right. At every cut, I should have done that, but it's as simple as that. You don't need to give left cuts and right cuts again and again. You can just simply sort this, because at any point of time, if this cut is there, then for sure I can just say if it is sorted, then if it is the cut which is being made, then all the left cuts are gonna go to the left stick, right cuts will go to the right stick. That's the reason I just took 4 variables: start stick, end stick, left cut, right cut. Right, these two will help us at any point of time. If I just make any cut, let's say I make a cut right here, then my stick will become the left stick parts will become start stick, end stick, and right stick part will become start stick, end stick. And similarly, here the left cuts, here the cuts are not there, so no worries at all, it will just go. But here the cuts will become okay, left and right. So now I can, in my recursive call, I can again go and iterate on those cuts with this help, because now it's a simple problem. Again, the new problem is made. The stick is there, the cuts are there. As simple as that. Again, if I just had a cut here, start stick, end stick, start stick, end stick, left cut, right cut, left cut, right cut. As simple as that. If I made a cut here, start stick, end stick, left cut, right cut, left cut, right cut. As simple as that. I just had the main stick, I have the cuts, I just broke that stick, I just made the left stick, I just made the right stick, I made the left cuts, I made the right cuts. Cool. That is the reason we know that we can easily solve this by simply having the start stick, end stick, left cut, right cut, and simply calling our again by like splitting a stick into half at the cut point, and then making it half left cut, left stick, and then left cut for that left stick and right cut for the right stick. Let's quickly see the recursion code. It's very simple. Exactly what I showed you. You have these 4 variables and you will put a cut at the cut point which is given to you in the problem itself, but make sure you sort that up, because you know that you have to give your left cut to the left side and right cut to the right side, and you don't want to iterate on the left cut and right cut again and again. So you will just sort it down so that you can just give the left cut to the left stick. As simple as that. Let's quickly see the code of recursion. Firstly, as I said, I need to sort my cuts because I need to give my left cuts to the left part and right cuts to the right part to actually evaluate faster. Now, I will simply, as I said, I need a start of the stick, end of the stick. I need the start of the cuts array and the end of the cuts array, right? Because you want start stick, start and end of the stick, and start and end of the cuts also, because for sure you are operating on cuts and stick. Now, as it goes on to the recursion, firstly, a very simple base case, because cuts are of left and right? And we are operating on cuts only, right? So cuts left and right. What if it just overpasses each other? So basically a simple condition, if left and right, because it's simply 2 pointers, if those overpass, I can simply return a 0. Now, a simple maximum condition, because I want minimum, remember, I want minimum total cost. So I just put by default the maximum total cost. Okay, it is a maximum total cost. By this maximum cost, what will happen is, again, I have this maximum cost, I will try to minimize this cost. And how I can minimize? I will just try every possible cut. I will go on from left to right, which means I'll go on to all the possible cuts from left to right. It is just going on to every cut, and then at every cut I know I have to bring the left stick, I have to bring the right stick. Left stick will have a starting as stick as start stick itself, but the left stick end part will become the cuts of I, because for sure it is being cut. The left stick, if I am doing a cut at I, so the left stick end part will become the cuts of I. The right stick starting part will become the cuts of I, and the end part will remain end stick. Thus, I will just say, okay, left stick starting part is start stick, and left stick end part is cuts of I. Right stick starting part is cuts of I. Right stick end part is end stick. Thus, okay, my cuts, my starting and ending is done. But now, what is the new cuts? New cuts, for sure. If it had been left, it had been cuts, as simple as that. If it has been left, it has been cuts. So it is cuts of I, right? So why not I minus 1? As simple as that. I just simply do a left, it remains same, left, it remains same, but I was the cut. But now the new cuts will be I minus 1. The new cut will be for sure I plus 1. So for sure, the cuts will have left or I plus 1, and the right part will have I plus 1 to right cuts. I plus 1 to right cuts. It was I. It was I. So the new cut on the left part is I minus 1, and the new cut on the right part is I plus 1. Right? That is simply how you will just put your cuts. And as simple as that, the new cost which you will incur is for sure the cost of your stick, which means this stick cost, which is end minus start. It is the cost as soon as you make a cut on this particular stick of length, end stick minus start stick. So it is the cost which you will incur, end stick minus start stick. And then I just call recursion, okay, what is the cost incurred if we just apply the operations on the left part and on the right part. And simple as that, take the minimum, because I want to apply the cuts on every point and take, okay, what is the minimum out of it? That is how you will easily solve this problem. Now, simple memoization, which we will do. Exactly simple, very simple, very simple. A 3-step memoization. Just initialize your DP array. Simply just check before going on to the recursion if it is not -1 or not. And as simple as that, while returning your case, return, okay, by just putting it in your DP. By this, you can simply do a memoization. By just 3 steps in the above code. As simple as that. But, you will say, Aryan, in the recursive call, I see 4 variables, but you memoized only 2. How is that even possible? That is the reason. I'll show you how is that even possible. As simple as that. If you will just see your left and right, it can actually, see, you had 4 variables, left, right, start, stick, and stick. Left, right are the cuts, start, stick, and stick are the actual stick lengths. But, left and right are more than sufficient to bring your start, stick, and end stick. Which means from your left and right, I can actually bring your start, stick, and end stick. Aryan, how is that possible? In the last example, you know, your left was here, right was here. If I just make your left, right, because left, right start from the cuts itself. Okay, left and right were the cuts, start, cut, end cut. What if I just push my cuts at the start of my, at the end of my array itself, which means at the end of my stick itself. So basically I shifted my left at the very start and the right at the very end. By this, what will happen is cut has also pointed now the cut, which was actually starting from the inner range. Now it starts from the end range by just pushing in. See, I just shifted my like least left to the exact 0 and the most right to the exact right. By this, what will happen is that I just simply added these 2 points in my cuts array. But by this, what happened is I can easily get my start stick and end stick by simply saying, okay, left index value is the start stick, right index value is the end stick. As simple as that. So rather now stick, this left and right are not pointing to the cuts. It is pointing to the stick location. That is the reason I am now pointing into a stick location. But then Aryan, how will you find the cuts itself? No worries at all. If at any point of time I just place a cut anywhere, then my left and my right, see, I just put a cut here at I. So I know the start stick by this left. I know the end of this left part by this I. I know the right part start by this I. I know the right part's end by this right. Because right will give me end stick. But how to know the cuts now? Because my main task was to know the length of the stick and the cuts also, which means the stick endpoints and the cut endpoints. I can easily say, okay, I just shifted my cuts 1 step, right? Which means the cuts are just 1 step away from where they should have been. So I'll just simply, when to find the cuts for this new location, I can just simply say, okay, the cuts for this new location are just 1 step in. So the cuts are actually starting at this location, which means left +1 and I -1 is actually the cut range. Here also, I +1 and right -1 is actually the cut range. That is the reason. From this left and right, you are able to find the start index and the end index and also the cut range. Cut range is just 1 step in, 1 step in. Why 1 step in? Because I actually moved them 1 step out. That is the reason. By this simple step, I can easily say, okay, my left and right are more than sufficient to actually memorize the solution. And I actually show you by modifying the code itself. If I just go at the code, I just simply not use my start stick and end stick at all, although it is in the code, but I'm modifying the code. Let's say I'm just writing the code by yourself. So basically, I just know for sure I have to move my cuts 1 step out, which means I have to push in my 0 and n, because now it will just move 1 step out. Now for sure, I know I will not use my start stick, end stick, so let's ignore them. As simple as that. And the sorting part was already earlier also, no worries on that part. Now comes the interesting part, that you have your start stick, end stick as ignored. Now you only have your left and right, but left and right are not the cut boundaries. It is actually the end boundaries of your stick. So firstly, earlier I had left is, earlier the condition was, see, earlier the condition was that left is more than right. But here we know that left and right are 1 step behind. So I just simply modify the condition. Okay, right minus left. If it is 1 or less than 1, for sure, I have just reached closer and I can't go much closer. Cool. The simple memoization as earlier we saw, simple, same case. Here also, earlier your left and right were the cut points, but now left plus 1 and right minus 1 are the actual cut points. That's the reason I just did a left plus 1, because I know, I told you, I need to move one step inside. Left plus 1 and right minus 1. Left plus 1 and right minus 1. Now, same, exactly same. Never use this. Don't use this. Simple. Left and I, which means see, your new cut range will be, when I say cut range, I actually mean the index of the stick itself. So it is left and I, which is this left, and the I, which I am grabbing, which is the new cut range, as you saw, right? The new cut range, as you saw, will be left and I, and right is I and right. As simple as that. So left and I and right. Now, what is the string length? String length is nothing but your right minus left, right? Your string length is nothing but yeah, right and left are the actual indexes. So I need length itself. So okay, cuts of right minus cuts of left, which will give me the actual length. And the left cost and right cost, we earlier saw how it is done. But you saw what is the difference. The cut range started from left plus 1 and right minus 1. That's the reason. Just cut ranges got changed, and that is how you can actually solve it. By just this simple thing got changed. Your cut range got changed, and simply you just modified and used your left and right instead of your start and end. By this you saw that start and end were never used. By this I can simply say that okay, my simple left and right is being used. That's the reason. I just quickly clean the code, and the code will look something like this. Exactly same code, just that okay, the cut, start and end I removed. Exactly same part of code which I showed you above. Just that I just removed, because I showed you without using start and end. That's the reason I just showed you that start and end are removed. Exactly same code, and that is also you can just copy from here. The complexity is nothing but n square recursive calls, because I and j, left and right, n square calls. For every recursive call, I'm going on to every cut. That's the reason it is nothing but n cube of time and space of n square for the memoization part, because it's a DP array. If you want to see the bottom up code, it's exactly same part, exactly same recursive call. It's just the modification that you just go in the reverse direction, because you want to compute the smaller cuts first, which means smaller areas, smaller length of sticks first. That's the reason. Exactly same code. It's just that I'm just going on in the reverse direction. That is the only thing in the bottom of code. Exactly same. You can just have a look at it. But still, the complexity is still same. So I highly recommend to just use this code. I will not recommend the code. I'll recommend the code I showed you in the beginning, which is this code, memoization code. It is the best code, which if I would have been there, I would have written this code. That's simple as that, because it is very intuitive and very easy to write. That's the reason I just went on from recursive to memoization like this, and then removing those areas to actually show you that okay, it is not required, which means starting and end stick are not required. I hope that you guys liked it. I tried to keep it as short as possible, as concise as possible. Thank you so much for watching.